Hey everyone, let's look at problem 3 from the first midterm in the spring 2020 offering of DSC 48. Okay, so suppose we're given a data set with at least 4 data points, because we're told to assume that the size is greater than 3, where the data points are in sorted order. Okay, that's all this is saying. And it says, suppose we argue that a good prediction H is one that minimizes the function R of H, is equal to something that kind of looks like mean absolute error, but is slightly different. And so we're told A, discuss the pros and cons of this prediction strategy, and B, what would this prediction strategy predict for the data set 2, 4, 6, 8, 11, 18, 19. Okay, let's try and decipher what this formula even means. Like I said, it kind of looks like mean absolute error, but wherever mean absolute error has an n, this has an n over 2, right? So regular mean absolute error looks like this. So this is almost the same. It just stops at n minus 2, right? And so if you expand this out, it ends up looking something like this. You have the absolute value of y1 minus h plus the absolute value of y2 minus h, so on and so forth, until the absolute value of yn minus 2 minus h. So this is actually just this is actually just minimizing regular mean absolute error if you ignore the data points yn minus 1 and yn. Right? There's no yn minus 1 here, and there's no yn here. And because we're told our data points are in sorted order, this is equivalent to minimizing mean absolute error after you get rid of the 2 largest data points. And what was the prediction that minimizes mean absolute error? Well, if we have an odd number of data points, it's the median. If we have an even number of data points, it's anything between the middle two. The median is one of those as well. So essentially, this prediction strategy boils down to getting rid of the largest 2 data points and taking the median of everything else. Okay, so in this prediction strategy, H star is the median of y1, y2, so on and so forth, all the way through yn minus 2. Okay, great. So it turns out it's actually easier to answer part B first. Then we'll talk about part A. So part B asks what prediction would be made for the data set 2, 4, 6, 8, 11, 18, 19. Well, remember, we're getting rid of the largest 2 data points, which in this case are 18 and 19, and we're taking the median of what remains. And in this case, the median here is 6. So for this data set, the prediction that this prediction rule, or not prediction rule, but prediction strategy would give us is 6. Okay, great. So now let's discuss, when would this be a good prediction strategy? Well, it would be a good prediction strategy if we have large outliers, right? Because we're essentially just removing the outliers and minimizing mean absolute error on everything else. Now, the median by default is already robust to outliers. It's not that sensitive to outliers as compared to the mean, for example. But if we just remove the outliers entirely, which is what this is effectively doing, then we're swayed even less by those outliers. So this would be good if you have large outliers, because it basically ignores them from the calculation. So similarly, when would this be bad? Well, this would be bad if you don't have large outliers. So if there are no outliers or small outliers, then you're removing the largest 2 data points. That's removing data that is like representative of the rest of the data set. It's like you're removing values from the middle almost, if the large values aren't really outliers. So this would not be great if the largest 2 data points are not outliers. So it's bad if no outliers or small outliers. And an easier way to simplify all that is no large outliers. Okay, let's illustrate what might happen with an example. Let's pretend we have the data set 2, 3, 9, 10, 11, 12. if we just minimize regular mean absolute error for this data set, what's the H star that we're going to get? Well, in this case, we have an even number of data points, so anything between or including 9 and 10 would be what's called the best prediction. So anything in the interval 9 to 10 would work. Okay, and that kind of makes sense because it seems like most of the values in this data set are, like 9, 10, 11, 12. We have a few small ones, which we could think of as being outliers 2 and 3, but this seems like a reasonable prediction choice. But if we now use this new mean absolute error defined in the question, what is H star? Well, we calculate it by getting rid of the largest two data points and minimizing mean absolute error on what's left. And so now we still have an even number of data points. We have 4. And so the best prediction is anything between the middle two values, which in this case are 3 and 9. So now H star is anything in the interval 3 to 9. But remember, we removed these largest two data points for the purposes of doing our calculation. They still exist in our data set. And so, let me draw this 2 again. We could say that, with this new prediction rule, 3.1 or like 3.5, for example, would minimize the function R of H, and so it would be the best prediction or one of the best predictions. But 3.5 would be a horrible prediction for the data points 9, 10, 11, and 12. And so in this case, this prediction strategy is actually pretty bad. So at a high level, this would be good if you have large outliers and bad if you don't have large outliers. Hopefully that was clear. If it wasn't, feel free to post on Campus Wire.